The James Webb Space Telescope, JWST, spotted something amazing, lights shining from a city far, far away. This has everyone talking about aliens again. The telescope was looking at Proxima Centauri b, the closest exoplanet to us, when it saw these weird, bright flashes. Could this be a sign of an advanced alien civilization? We'll have to wait and see. People have been dreaming about finding life on other planets forever. So, any hint of aliens gets people excited. The JWST gave us something big, suggesting there might be life out there. While checking out deep space, the telescope found something strange on an exoplanet, lights that looked like they came from cities. Could there be an alien city on that distant planet? This has made scientists really curious, because it might be the big find they've been hoping for. It might mean intelligent beings are out there, with civilizations we're only starting to figure out. These city-like lights are super far away, for light years. NASA folks are amazed, wondering how long these lights have been shining, just waiting for us to get the tech to see them. David Kipping, an astronomer at Columbia University, said the planet where they saw the lights is really strange. Most rocky planets soak up sunlight and send out energy as infrared radiation, but this exoplanet is different because of how it hangs out with its star, Proxima Centauri. This shows how important the JWST is. It can see infrared light, which was key to spotting the weirdness of Proxima Centauri b, which helps us understand what's going on with the planet's atmosphere. Researchers plan to keep using the telescope to check out the planet's atmosphere, hoping to figure out if it could support life. The JWST is really good at spotting infrared light, so it can see things on Proxima Centauri b, even at night. Lots of telescopes can't see faint light in space, but the JWST is great at picking up even the dimmest glimmers. That makes it perfect for confirming if those city lights on the dark side of Proxima b are actually there. The telescope can spot artificial light in space as long as it's in a certain frequency range, much tighter than the light from normal stars. Proxima Centauri b is super affected by its star. Like other planets orbiting stars, it gets a ton of energy from Proxima Centauri. As the planet goes around the star, it goes through day and night, just like Earth. It gets super hot during the day and cooler at night. The temperature range on Proxima Centauri b is huge, mostly because of what it's made of. If it has an atmosphere, the temperature difference between day and night would be extreme, hot on one side and freezing on the other. This crazy temperature change is something astronomers are really interested in because it gives them clues about what the planet's atmosphere is like. Since the JWST can take pictures in infrared, it can check out the planet's heat and learn about its atmosphere. What's cool is that the JWST orbits Earth at the same rate that Proxima Centauri b orbits its star. That means scientists can watch its daylight cycles closely every 11.2 Earth days. If Proxima Centauri b has an atmosphere, the next step will be to figure out what's in it to see if it could support life. Finding things like oxygen, water vapor, and methane would suggest the planet might be able to host life. This means studying the light that goes through the planet's atmosphere, which is tricky. While the JWST is great at figuring out planetary atmospheres, it's really designed for other stuff. It's good at figuring out how much water vapor, carbon dioxide, and methane there is, but not as good at finding free oxygen, which is a big sign of life. Still, the telescope can look for other clues, like ozone, which means a healthy atmosphere. As scientists look at the data from the JWST, the hunt for planets goes on. The search is getting us closer to answering if we're alone in the universe. It's worth knowing that the JWST can only see a few of the exoplanets closest to Earth. To really dig into planetary atmospheres, astronomers will use ground-based telescopes like the Extremely Large Telescope, ELT, which should be up and running in 2027. The ELT will give us a better look at the atmospheres of faraway exoplanets, giving us clearer info on whether they could support life. Scientists are waiting for future space telescopes like the ELT to launch, but the JWST is still a valuable tool for checking out distant exoplanets. Even with its limits, the JWST keeps giving us important info that might change how we see what's out there. Researchers have big plans for future space telescopes. They want to make tech that blocks starlight better, so we can see the planets around them more clearly. It's like using your hand to block the sun so you can see better. These telescopes will be able to focus on the faint light that exoplanets reflect, making it easier to check out their atmospheres and see if they could support life. But it's not easy. Stars are super bright, often way brighter than the planets around them. This makes it hard to see the faint light that planets reflect, which we need to study them. To fix this, scientists are working on new ideas. One idea is to use coronagraphs, which are devices inside telescopes that block out starlight but let the light from the planet through. By carefully shaping the light waves, coronagraphs can cut down on the brightness from the star, making it easier to see the dim light from exoplanets. Another idea is the Star Shade, a huge flower-shaped spacecraft that will fly with a telescope tens of thousands of kilometers away. The Star Shade blocks starlight before it even gets to the telescope, so only the light from exoplanets gets through. This could be really good for seeing planets in the habitable zone of their stars, where there could be liquid water and maybe life. But these technologies have to be super precise. For example, a star shade has to be aligned perfectly to within fractions of a millimeter over huge distances. They also have to deal with the problems of space missions, like being small, using energy efficiently, and dealing with the harsh conditions of space. Even with these challenges, it's worth it. If we can see and study the atmospheres of exoplanets, we might find biosignatures, chemical signs of life, like oxygen, methane, or water vapor in the right amounts. These molecules could mean biological processes are happening, hinting that there's life out there. Researchers are also looking into getting direct images of distant planets in more detail. Future telescopes could have advanced adaptive optics, which fix distortions from Earth's atmosphere or the telescope's movements, making images sharper. If we combine these with starlight blocking tech, we could not only find exoplanets but also map their surfaces and study their climates. Making these new space telescopes is a big step in trying to answer one of the biggest questions: are we alone? By getting better at seeing these distant planets, we're getting closer to finding out if there's life out there, which could change how we see our place in the universe. Space exploration and the search for life are speeding up. As scientists dig into the mysteries of distant exoplanets, the JWST is starting a cosmic discovery. The info it's giving us is helping astronomers make big finds about the structure, what they're made of, and if they could support life. Every new bit of info gets us closer to figuring out, is there life out there? Finding Proxima Centauri b is just the start of what could be a big change in how we study alien life. Since Proxima Centauri b is the closest star to us, it's been studied a lot. But until now, finding real signs of life, like artificial light or civilizations, was just a dream. The fact that the JWST has seen this light makes people think that we might contact other intelligent life in space one day. This makes scientists curious and gets people excited, inspiring new generations to think beyond Earth. As the JWST keeps watching, it's not just looking for artificial lights. It's also looking at planet atmospheres, what's in them, and how that could support life. Finding biosignatures like methane or carbon dioxide in the right amounts is key to knowing if these planets have the right conditions for life. The JWST can check out these atmospheric things in a way no other telescope has, showing us if distant planets could support life like Earth. One of the coolest things about Proxima Centauri b is where it is, in the habitable zone of its star. That means it might have liquid water on its surface. The habitable zone is where it's not too hot and not too cold for liquid water to exist. Water is necessary for life as we know it, so finding a planet in a star's habitable zone is a big goal for future missions. Besides finding planets that could support life, future space telescopes will also look at how exoplanets and their stars affect each other. Some planets, like Proxima Centauri b, are tidally locked. That means one side always faces the star, and the other side is always dark. This can make the temperatures on the two sides of the planet very different, which would affect the planet's climate and if it could support life. Knowing these things is important for astronomers when they're figuring out if exoplanets could be habitable. Making tech that can block the bright light from stars is another big step in space exploration. If we can't block starlight, it's almost impossible to see the faint light from distant planets. The coronagraph and star shade tech I talked about earlier are good examples of how scientists are dealing with this. By blocking the bright light of a star, these tools let telescopes see the faint light from planets orbiting it. This light can tell us important things about a planet's surface, atmosphere, and even if it could have life. One exciting thing is the idea of directly imaging exoplanets. By using advanced adaptive optics and light-blocking stuff, astronomers hope to get high-definition pictures of planets as they orbit their stars. These pictures could not only tell us more about a planet's atmosphere and what it's made of, but also show things like bodies of water, land, or big weather systems, giving us an amazing look at distant worlds. This would be a huge step in checking out habitable exoplanets and understanding if they could sustain life. As the world works together to explore space, the James Webb Space Telescope, JWST, and future missions will be key. The JWST's ability to spot faint energy, break down atmospheres, and look for possible biosignatures is changing astrophysics. As tech gets better and we understand more, we're getting closer to finding out if there is anyone out there, which could change everything.